Chapter 3.5, exercise 1 through 18. This section has to do with equation solving and modeling, and specifically exponential equations, logarithmic equations. In exercise 1 through 10, find the exact solution algebraically and check it by substituting into the original equation. So we have 36 times 1/3 of the power of x over 5 equals 4. So I'm going to first rewrite this equation. We have 36 times 1/3 to the power of x over 5, and that is going to be equal to 4. The first step we're going to do is we're going to try to isolate back to this x over 5. Our first step is going to be to divide both sides of this equation by 36. And 36 over 36 cancel on the left side. So we have 1/3 to the power of x over 5 equals to this 4 over 36 simplifies and reduces to 1/9. And what we're going to do is look for a common base between both sides of this equation. Well, if we can adjust one of the bases to be consistent with the other one, that's what we need. So what I'm going to do is take this 1/9. I can rewrite 1/9 as 1/3 squared. That's going to be equal to 1/9. So therefore, what I can do on the left side is just rewrite the equation. We have 1/3 to the power of x over 5. On the right side, we replace 1/9 with 1/3 squared. And now we have on each side of the equation 1/3 to the power of something, and that something is, in each case, in the exponent's place, we have on the left side an x over 5, on the right side of the equation we have in the exponent place 2. So x over 5 is equal to 2. And if we cross multiply that 5, we'll rewrite that. If we rewrite that equation, we cross multiply the 5, we're going to have x is equal to 10. And that should be our answer, but we're going to substitute into the original equation. So here, on this equation up here, I'm going to do this in red. We have 36 times 1/3 to the power of 10 over 5. And we should have that equal to 4. Well, this 10 over 5 simplifies to 2, so we have 36 times 1/3 squared equals 4. And 1/3 squared, 1/3 squared is 1 over 9, so we have 36 over 9 is equal to 4, which simplifies to 4 equals 4. Check. So now we're sure that x equals 10. That's our first on our problem, 1. Next on our problem, which is 3, we have 2 times 5 to the power of x over 4 is equal to 250. The first step, we're going to divide both sides of this equation by 2. And we do that, we have 5 to the power of x over 4 is equal to 250 divided by 2, which is 125. So can we rewrite 125 as a power of 5, since we have a base of 5 on the left side? Yes. 5 squared is 25, but 5 cubed, or 5 to the 3rd power, is equal to 125. So on the right side, I'm going to rewrite, okay, left side I'm going to put 5 to the power of x over 4. But on the right side, I'm going to put, instead of 125, I'm going to put 5 to the power of 3. And so now, in the exponent's place, across the equal sign, we have x to the 4th x over 4 is equal to 3. And cross multiplying, if we cross multiply 4, x is going to be equal to 12. And that should be our answer, except we're going to check. And so in the original equation, we have 2 times 5 to the power of 12 over 4, and that should be equal to 250 if we've done everything right. Okay, 12 over 4, the left side simplifies to 3, so we have 2 times 5 to the third power equals 250. And then 2 times, well, 5 cubed is 125 equals 250. And finally, you multiply 2 times 125 with the left side, we have 250 is equal to 250. So we box in our answer, box in the check, and then we come back here and box in our answer, x equals 12, as our correct answer. Next on our problem, which is 5, we have, I'm going to rewrite 2 times 10 to the power of negative x over 3 is equal to 20. And if we divide both sides of this equation by 2, and 2 over 2 on the left side cancel to equal 1, we have 10 to the power of negative x over 3 equals 25 by 2, which is 10. And this will be 10 to the first power. So in the exponent's place on the left, we have negative x over 3, and in the exponent's place on the right, we have 1. And so if we cross multiply the 3, we have negative x is equal to 3. And then if we multiply both sides of this equation by negative 1, we have negative 1 times negative x is going to be x, and then negative 1 times 3 is going to be minus negative 3. And we box this in as our correct answer. Next on our problem, which is 7, here we have a logarithm of, and this would be the common logarithm, log base 10 of x equals 4. So just rewriting this, we would say log base 10 of x is equal to 4. And so the logarithm essentially is a form of exponential relation. So this expression here, log base 10 of x equals 4, is saying 10 to the power of 4 equals what number? Now, if we had a number, log of a number equals x, then it would be 10 to the power of what equals that number here. And so we can rewrite this logarithmic equation as an exponential equation by doing this. We say 10 to the power of what's on the other side of the equal sign, 4, is equal to x. So 10 to the third power is 1,000. 10 to the fourth power is going to be 10,000. So 10,000 is equal to x, and that should be our answer. We're going to plug this into our original equation for testing purposes according to the instructions of the problem. So we're going to say log base 10 of 10,000 is equal to 4. We can rewrite this 10,000 as 10 to the fourth power, so we can rewrite this as log base 10 of 10 to the fourth power is equal to 4. Well, that would be 10, just we have 10 to the power of 4, because 10 to the power of what equals 10 to the fourth power? Well, 10 to the power of 4 equals 10 to the fourth power. So they equal each other, so check. So we're sure that 10,000 is our current market value for x. Next on our problem, 9. We have log base 4 of x minus 5 equals negative 1. So I'm going to put this here, log base 4 of x minus 5 is equal to negative 1. So it's a similar strategy to what we employed here in problem 7. So 4 to the power of what? Or negative 1. So 4 to the power of negative 1 equals, we bring this x minus 5 over on the right side, equals x minus 5. So it's kind of like we're doing a little bit of a diagram here. This negative 1 comes over here and becomes the power of this 4 here, and this x minus 5 just goes over to the other side of the equal sign. So that's conceptually what we're looking at. Let me just move some of those. Okay, now 4 to the negative 1 power is the same as 1 over 4 to the 1 power, or 1 over 4, and that's going to be equal to x minus 5. And so to solve for x, we add 5 to both sides of the equation. So x is plus 5, plus 5. We have x equals 1/4 plus 5, which decimalized equals 5.25. There we are. And then we're going to test the original equation. If we're going to say log base 4 of x, and x is going to be 5.25 minus 5 equals negative 1. And so that's going to be log base 4 of 5.25 minus 5 is going to be 1/4 is equal to negative 1. I'm sure it's just more legibly written. And so we can rewrite this back in a exponential form as 4 to the power of negative 1/2 is equal to 1/4. And I said 4 to the power of negative 1/2. I meant to say 4 to the power of negative 1 equals 1/4. And so we're going to have 1/4 is equal to 1/4. Check. So we know that our answer is x equals 5.25. 5 1/4. There that is. That's problem number 9. Next on our problem, 11. Exercise 11 through 18, solve each equation algebraically. Obtain a numerical approximation for your solution and check it by substituting into the original equation. So in this case, we have 1.06 to the power of x equals 4.1. And we're going to go backwards and make this base of our exponent a base of a logarithm. So our rewrite is going to look like this. We're going to rewrite this as log base 1.06. The base of the exponent becomes the base logarithm of 4.1 is equal to x. And for this, in this form, for many calculators, we have to use what we call a change of base formula to find the numerical solution, numerical approximation, it says. And for that, we can take x is going to be equal to the natural logarithm of 4.1 divided by natural logarithm of 1.06. And I'm going to go to our calculator on this. Okay, control And again, those numbers are 4.1, 1.06. And we press the Control and E to the X key. 4.1. You go back here. 4.1 over the natural logarithm of 1.06. And for that, we get 24.2151. And we're going to check our original thing here, and to do that, I'm going to just store a value for 24.2151, and we're going to say Control negative sign, which is ANS, and then Control vars for storage, we'll say A. So we stored for A, and we want to find 1.06 to the power of x. So going back to our calculator, we put 1.06 to the power of a, and we get 4.1, which is where we came from originally, so that checks. So that checks, so we know that x is going to be approximately equal to 24.2151. Next on our problem, which is 13, we have 50e to the 0.035x equals 200. We're going to divide both sides of this equation by 50. And then 50 over 50 cancel on the left side. So we have e to the power of 0.035 x. And on the right side, we have 200 divided by 50, which is 4. So we can take, we can change this into a logarithm, in this case, a natural logarithm. So we have ln, natural logarithm, equals log base e. So we're going to write this as the base of the exponent becomes the base of the logarithm. So we're going to have log base e of 4 equals 0.035x. And this log base e is the natural logarithm, so we're going to rewrite this as ln of 4 equals 0.035x. And solving for x, if we divide by 0.035 both sides of the equation, so they don't mark off. So we have x is equal to the natural logarithm of 4 over 0.035. Okay, so let's do that. Natural logarithm of 4 divided by 0.035, and for that we get 39.684. Okay, and we're going to be testing that with 50 times e to the 0.035 times 39.684. So here we go. To the calculator, 50 times e to the power of 0.035 times, I'm going to press Control negative sign for A and S, and for this we get 200 back again, so that checks. So we plug back in, that checked. We know that our value for X is very close to 39.6084. Next, under problem 15, we have 3 plus 2e to the negative x equals 6. And for this, we're going to subtract 3 from both sides of the equation as an initial step. So we have 2e to the negative x is equal to 6 minus 3, which is 3. Next, if we divide by 3, divide by 2, where am I dividing by 3? Yeah, we need to divide by 2. So dividing by 2, we have e to the negative x is equal to 3 over 2. And we can rewrite this as a logarithm, and that is the base of the logarithm becomes the base of the exponent. So we have ln, which is log base e, of 3/2 is equal to negative x. And next, if we divide both sides of this equation, or multiply both sides of the equation for this matter, by -1, we cancel out on the right side of -1, we have natural logarithm of 3 over 2 over -1 is equal to x. So now, going ahead and doing that in the calculator, we have natural logarithm of 3 over 2, I'm just going to put 1.5, divided by -1, and I get negative 0.405465. .405465. So that's going to be negative 0. So that's going to be what our answer should be, but then we're going to plug this back into our original equation. So we're going to put 3 plus 2e to the negative this number here for x. So doing that, we have 3 plus 2 times e. Oops, I put ln. I'm going to put e. E to the, see what that looks like here, negative x. Okay, so we'll go here and put negative x, and to find that out, we're going to put last number calculated, which is going to be second ANS, and that's going to give us 6. So that checks out 100%. And so we are sure that x equals negative 0.405465. Last other problem we're going to look at is 17, and that's going to be 3 times natural logarithm of quantity x minus 3 plus 4 equals 5. So the first thing I'm going to do here is subtract the 4 from both sides of the equation. So we have left 3 natural logarithm of x minus 3 is plus, well, we subtract out 4, so we can just go ahead and equals 1. Next, if we divide by 3, We have 3 over 3 cancel to equal 1. We have natural logarithm of x minus 3 is equal to 1/3. And now we can take, we have log base e, so we're going to have e to the power of 1/3 is equal to x minus 3. So if we add 3 to both sides of this equation, we have, I'm going to bring this up here, we have x is equal to e to the 1/3 power plus 3, and that's going to be the e to the 1/3 power is the cube root of e plus 3. So we're going to do this in our calculator here. We're going to say the cube root, there's the cube root of, we're going to go to e, so we press e, and we'll say e to the first power, and I think that's going to be plus 3, so we get 4.39561 for x, 4.39561, and the last thing we're going to do is check, so we're going to take 3 natural logarithm of parentheses x minus 3. So on our calculator, 3 times the natural logarithm of x, well, for that I'm going to use ANS, control, negative sign, and that's going to be, what is that going to be, minus 3. Okay, minus 3 in parentheses, and then outside parentheses, plus 4, which should get that right side, which is going to be 5. And going back, we see that, yes, that does check. So x is going to be very, 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 very close to 4.39561. So that's all the odd number problems worked out in this set. Good luck on your even number problems as a demonstration for learning, and I thank you for viewing.